In the specialized field of coring, the new Quick line, including Quick Core, Quick Drill, Quick Closure, and of course our pressure system, QuickCapture, are just some of the revolutionary new technologies bringing added value to oil and gas operators all around the world. The revolutionary technology behind QuickCapture has been developed to collect in-situ gases and liquids, giving a complete and accurate picture of the reservoir to guide productivity while speeding up the decision-making process. QuickCapture coring operations can be operated on both the conventional and wireline coring platform. The following animation depicts an example of running the technology on the Quick product line. The Quick Drill can be used to drill out the casing shoe, drill to the core point, and after coring to drill to TD without tripping the drill pipe. The drill insert is either set at surface or lowered into place via wireline and can be removed and reinstalled at will without tripping the drill pipe. Switching from coring to drilling can be done in a matter of minutes, saving valuable time for the operator. Mud circulation can be maintained at all times, while the Quick Drill insert is being set or retrieved, further improving well safety. Once coring is underway, the core is stored safely and securely in the inner barrel of the coring assembly. Once the barrel is filled, the inner barrel assembly can be extracted from the core barrel via wireline. Once the QuickCapture coring interval has been identified, the pressure coring assembly is pumped into place using the same wireline platform without having to trip tools out of the hole. The QuickCapture outer assembly consists of the same swivel assembly, outer barrel, and core bit. The inner assembly consists of a gas storage canister meant to collect any expelled gas or fluids during the trip out of the hole. The telescoping sleeve is used to collect the core. Pressure and temperature transducers are to monitor coring operations and the trip out of the hole. All of the core and associated gases and fluids in the tool are sealed by proprietary sealing mechanism. Coring then commences, collecting up to 10 feet or 3 meters. After the interval is cored, the assembly is hoisted off bottom to break the core at the bit. The wire line is run down and latched onto the QuickCapture coring assembly. An initial pull begins to set and stroke the tool, allowing the core to pass the valve assembly and seal the tool. A secondary pull disengages the tool, and the inner barrel starts the trip to the surface. As the tool is tripping out of the hole, all gases and fluids that are expelled from the core barrel are collected in the canister on top of the tool. The tool is not allowed to reach any pressures above 1000 psi, so as the tool is tripping out of the hole, all gases and fluids that are expelled from the core barrel are collected in a storage canister on top of the tool. Each canister is fitted with a pressure crack valve and pressure and temperature recording transducer. The pressure relief valve works by a pressure differential preset on the tool to allow communication between the barrel and canisters once the desired pressures are met. As another safety precaution, the tool is fitted with a pressure relief valve on the barrel and canister. In case of any failures in the tool due to plugging or malfunction, pressure will be released from the tool until it falls below the set operating pressures. Once the tool reaches the surface, it's laid down and the barrel and canister recovery process begins. The tool assembly is broken down into separate components. Pressure and temperatures are downloaded from the barrel and canister to ensure downhole operations were successful, and the components can be safely managed in the on-site laboratory. The on-site lab is designed to handle multiple cores and canisters simultaneously. As the core barrel is still a live system, it becomes the first priority once in the laboratory. The temperature of the tool can be increased, maintained, or cooled to match the reservoir type or reservoir conditions. Custom designed heat blankets can be utilized to simulate reservoir conditions. The barrel's temperature and pressure is continually monitored during the depressurization process. At first, the pressure between the barrel and the separator is slowly equalized to minimize dramatic pressure drops that may affect the quality of the core. Fluids are separated out to eliminate contamination into the downstream analytical equipment. Pressure from the barrel is transferred to a pressure management panel to monitor the barrel and control pressure transfer to the gas measuring devices. The panel can monitor up to 3 individual barrels or canisters simultaneously. A mass flow meter is set to control flow to the measuring devices. Initial flow rates are measured using a wet test meter. Gas samples are routinely collected for future composition and isotope analysis. A gasometer is utilized as a redundant empirical measuring device to validate total measured gas. In low gas volume situations, a manometer will be utilized. All fluid from the separator is collected for future laboratory analysis. Once the core has reached atmospheric pressure, the core is ready to be transferred. The extrusion process begins by draining and collecting fluids from the barrel. The core is then transferred to a sealed shipping canister. All remaining fluids are extracted from the barrel and combined with previous collected fluid. The canister is depressurized in the same manner as the barrel. All remaining gas is measured by pumping the piston back to its original position. After all of the gases have been measured, the remaining fluid is extruded and collected. All samples collected are properly labeled, measured, and recorded before being packaged and shipped. The Quick product line produces a thorough, cost-effective solution to operators' formation evaluation challenges by securing the recovery of a quality core regardless of the formation type, whilst leaving the well in the optimum conditions for logging, casing, and ultimately optimized production.